Okay, so this is section 9.4, more with angles and arcs, just in different arrangement. And what I wanted to do is start with just a little bit of review of the rules that we've learned already. Really, we've only learned two rules that have to do with angles and arcs. So our first one is if our vertex is at the center of our circle. That's the first one we've learned. Our vertex is at the center of our circle. So here's my circle, and here's my angle. So this is what we call the central angle. And a rule for the angle and the arc when our vertex was at the center was the angle equals the arc. The measure of the angle equals the measure of the arc. We're using kind of shorthand here. And if we wanted to write it even shorthand, I would say angle equals arc. All right, let's put the electronics away, please. So that's our first rule. Angle equals arc if our vertex is at the center. Our second arrangement was if our vertex was on the circle. So that was the second rule that we learned. And I'm going to draw a couple different pictures. The one that we have seen mostly is when our angle looked like this. So our vertex is over here on the circle. And we said our rule for that was to go from the angle to the arc. We multiply by 2, and to go from the arc to the angle, we divide by 2. So that was our second rule. This rule also works anytime the vertex is on the circle. So I could also have my angle arranged where one side is a tangent. So let me draw that picture. So one side of my angle is going to be a tangent like so. And the other side is going to be just a chord. So there's where they're tangent. And the rule here is exactly the same. Anytime the vertex is on the circle, I have the same rule. So this same rule would work to go from the angle to the arc, multiply by 2, to go from the arc to the angle, I divide by 2. So for that rule, it doesn't matter how the angle is arranged as long as the vertex is on the center, or on the circle. We multiply by 2 to get the arc, divide by 2 to get the angle. So here we have a tangent rather than a chord or a secant. Same rule. So those are the two rules that we learned so far. Today we're going to learn two new rules. The first one is for the vertex in the circle, but not at the center. And I'll draw, we can have our angles arranged in a couple of different ways. So our pictures for these are going to, we could have two secants like this. And our vertex is not in the circle. I'm sorry, not in the center. Our vertex is in the circle but not at the center. And I could also have two, it could be two chords. So I could just have something like so. So either of these two arrangements, my vertex is inside the circle, but it's not at the center. So we have a rule that we're going to talk about for this situation. So the measure of the angle is half the sum of the intercepted arcs. And the shorthand that I use for this is I say angle equals the arc plus the arc divided by 2. So what we're talking about here is if we're talking about this angle would be the arc, the intercepted arc, the arc that's at the side of the angle. And this arc, you would add those two together, arc plus the arc divided by 2. So this angle here, I have this intercepted arc and this intercepted arc. Over here, if I were talking about this angle, I would have this intercepted arc, and go in the opposite direction, this intercepted arc. So the angle equals the arc plus the arc divided by 2. So that's our first rule. So vertex in the center, not at the, or sorry, in the circle, vertex in the circle, not at the center. So let's look at a couple of examples using this rule. So here is our circle. We'll use secants for these examples. So there are my two secants. And for this problem, we know that this arc is 20 degrees. This arc is 60 degrees. And I'm going to call this point V for the vertex, and A here and B here. So we want to find the measure of angle AVB. So we have our nice new rule here. Our vertex is in the circle. It's not at the center. The center would be down here somewhere. So our rule, the angle equals arc plus the arc divided by 2. So I'm going to say the angle is 60 plus 20 divided by 2. So just to write it out a little more, measure of angle AVB, 60 plus 20 is 80 divided by 2, which is 40 degrees. So the measure of angle AVB is 40 degrees. Add the two arcs, divide by 2. So questions on that example? So based on what we've learned so far, the problems that we do aren't always going to be this easy, but this is the basic idea. Let's look at a problem where our information goes, the information makes us solve for another part of our formula. So for this one, we want to find one of the arcs. So here's our circle, our two secants. They intersect inside the circle, but not at the center. That angle is 50 degrees. That angle is 80 degrees. And we'll call this point A and B. And this is X degrees. And we want to find what we're looking for is the measure of arc AB. So we have an angle in the arc. So how are we going to go about solving this one?
Would be 80 plus X divided by 2 equals 50.
Right. So what we're doing here, just to backtrack a little bit, plug everything we have into the formula, solve for the part that we don't have. So the angle, our formula is angle equals arc plus arc divided by 2. And what Lyndon said was The angle is 50. That equals 80, one of the arcs, plus x, the other arc, divided by 2. All right, how are we going to solve this for x? What do we want to do next? Eventually. Multiply by 2 on both sides to get rid of that 2 in the denominator. We don't want this fraction. So 2 multiply and divide by 2, I just end up with 1. So I end up 2 times 50 is 100, equals 80 plus x. Now we're home free. What do? Subtract 80, nice and easy. And x equals 20 degrees. If you do these problems, you get a negative for an angle or an arc, you know you've made a mistake somewhere. Your angle or your arc should always be positive. Questions on that example? All right, so there's our newest rule. The angle equals the arc plus the arc divided by 2. Vertex inside the circle, not at the center. All right, let's look at our second rule for the day. This is for our vertex outside the circle. And I'll draw a few pictures of how our how our circle and our lines might be arranged here. So I could have two secants. So let me draw my two secants. There's my vertex is outside the circle. I just want to make this. I could have two tangents. So there are my tangents. Or I could have a secant and a tangent. So something like this. So in all of these cases, I have the vertex outside the circle, and then the sides of the angles intercept. The sides of the angle intercept two different arcs. So here's one arc, here's the other arc, here's one arc, here's the other arc, one arc, other arc. So these are the three situations where a vertex can be outside the circle. So our rule is kind of like the last rule. So the measure of our angle here is half again, half the difference of the intercepted arcs. And difference means what? Subtract, right? And in shorthand, if we want to write this out in shorthand, I write the angle equals the arc minus the arc divided by 2. And to make sure that our arcs and angles always turn out positive, we want to do the big minus the small. So we always start with the big arc, subtract the small arc, so we end up with a positive number. So our angle equals the arc minus the arc divided by 2. So this would be the big arc, this would be the small arc. Here's the big arc minus the small arc, big arc, small arc. So questions on our rule? Our rules so far aren't complicated, just remembering when to use which one. All right, let's look at a couple of examples using that rule. So here's our circle, we'll do secants here. So there's our problem. And we'll start with the easy one. 30 degrees. That arc's 80 degrees. And we'll call this A, and our vertex V and B. And we want to find the measure of angle AVB. Our vertex is outside the circle, so we can just use our new rule. So our rule is angle equals arc minus arc divided by 2. So the measure of angle AVB. So how are we going to set this one up? What do we want to do, Tanner? W? 80 minus 30 divided by 2. Big arc minus small arc divided by 2. So that's going to be measure of angle AVB. 80 minus 30 is 50 divided by 2, and I get 25. And if I would have made a mistake and done the small minus the big, 30 minus 80, I would have gotten negative 50. And when I divide by 2, I get negative 25, and that would tell you made a mistake. So you don't want a negative angle. So this one we just plugged into our formula. Not too bad. Questions on that one? All right. So let's look at one where we're finding the arc rather than the angle. So here's my problem. And we know that this is 130 degrees. This arc is x degrees. And my angle, it's kind of small, I can't write it in there, so we'll call it AVB again. The measure of angle AVB is 60 degrees. So that's this little red angle in here. So the measure of angle AVB is 60, and we want to find x. So our vertex is outside the circle. So our rule is angle equals arc minus arc divided by 2. And how are we going to set this one up? What are we going to want to do here, Jonas? Trying to find the arc. The angle is 60. Well, let's step through it. This says the angle equals the arc minus the arc divided by 2. Problem tells us the angle is 60 degrees. So I'm going to put that here for the angle. So 60 equals, and we said we want to start with the big arc. So which arc is going to be the big arc? 130 or x? 130. So we're just going to plug everything we know into our formula. 130 minus what's our other arc? X. And our formula says to divide by 2. Perfect. So our angle is the arc minus the arc divided by 2. Next step here, what do we want to do? Multiply both sides by 2. Just like the last problem, those cancel out. I get 120 equals 130 minus x. Next step, what do I want to do, Preston? Minus 130. 120 minus 130 gives me negative 10 equals negative x. How do I get rid of those negative signs? Multiply by negative 1, divide by negative 1, something. So I'll divide both sides by negative 1, and I get x equals 10 degrees. So, just like we've done a lot of times in the past, if we have our formula, we're trying to find one part of it, plug everything we have into the formula, solve for the part that we don't have. And if you get a negative for your angle or your arc, then you made a mistake somewhere. Your angle or arc should always turn out positive. Any questions? All right, so now we know 4 rules. For vertexes at the center, the angle and the arc have the same degree measure. If our vertex is on the circle, no matter what, no matter how it's arranged, multiply by 2 to get the arc, divide by 2 to get the angle. If our vertex is inside the circle, but not at the center, the angle equals the arc plus the arc divided by 2. And then our last rule finally, if our vertex is outside the circle, no matter how it's arranged, the angle equals the arc minus the arc divided by 2. So now we have 4 rules to work with. Now in the homework, you'll have to use, like we had on the quiz yesterday, you have to use what you know about triangles, what you know about linear pairs, all the different stuff that we've learned already to help solve the homework problems, but they also involve these rules for circles. And we didn't have any homework last night, so don't need to pass out the folders. So here's your homework for today. There you go.